So in this problem, we need to determine the equation of a circle which passes through the point 7, 3. And this circle has a radius of 3 units and its center is positioned on the line y equals to x minus 1. So let's first try to understand the problem graphically. So here we have the Cartesian plane with the x and the y axis. First, let's try to sketch the graph of the line y equals to x minus 1. So here the line y equals to x minus 1 can be easily graphed by using the x-intercept and the y-intercept. So let's first find out the x-intercept of the graph. To find out the x-intercept, all we have to do is we'll suppose that the y value goes to 0. So when y value goes to 0, this is going to help us find out the value of x. So that's going to be equals to 1. So we'll say that this is 1, 0. This is the x-intercept of our line. Then we will find out the y-intercept of the line. It will be the other way around. So to find out the y-intercept, we'll suppose that let the x value goes to 0 such that solving for y, we get negative 1. So y equals to negative y is going to lie on the negative y-axis. So we have 0, negative y. So that means our line is going to pass through these 2 points. Now let's also try to find the point 7, 3 approximately on this graph. So let's say assuming that the point 7, 3 lies somewhere here. And it has to follow the criterion that we have a circle and this circle is going to pass through this particular point, and the circle must be such that the center of this particular circle must lie along this line, or it should lie on the line. So let's call the center as C. So we will begin by first finding out the value of the center. So let's say the center is given by alpha, beta. So let that be the center of the circle. So let alpha, beta be the center of a circle. Now because the center lies on the line, so it must definitely satisfy the equation of the line. So let's since alpha, beta, this particular point, which is the coordinate of the center, lie on the line y equals to x minus 1. So that means it must satisfy the equation beta equals to alpha minus 1. All we have done is replace the value of y with the y coordinate value beta and x with the x coordinate value alpha. Now that means beta can be expressed in terms of alpha as alpha minus 1. Now that means our center is actually alpha, beta, but instead of beta we'll use alpha minus 1. We'll use only one parameter. Although we started with a 2 parameter, to keep life simple, we're using only the parameter alpha here. Now our next task would be to find out the value of alpha. For this we're going to join the center and the point 7, 3. Let's call it point P. So we can use distance formula to find out the radius. So the radius, which is r, that's given by CP. So this will be equals to, so we have square root of, underneath the square root we'll have to first take the difference of the x coordinate. So we choose x coordinate as alpha minus 7, we'll have to square it and then add it to the square of the difference of the y coordinate. So y coordinate is alpha minus 1 minus 3 whole square. So this will be equals to square root of alpha minus 7 whole squared plus alpha minus 4 whole squared. So this is the value of r. So it's already given that the radius of the circle is 3 units. So we'll replace the value of r with 3. So 3 will be equals to underneath the square root. So let's expand it. We have alpha squared minus 14 alpha plus 49 added to alpha squared minus 8 alpha plus 16. So this will be equals to 3. So we'll get rid of the square root by squaring both sides. So we have 9 equals to, so alpha squared plus alpha squared gives us 2 alpha squared. Then we have negative 14 alpha and negative 8 alpha, so that's going to give us negative 22 alpha. Then we have 49 plus 16, so that's going to be 65. So finally we get 2 alpha squared minus 22 alpha plus 56 equals to 0. We're going to further reduce this by dividing each terms by 2. So we get alpha squared minus 11 alpha plus the 28. So that's equals to 0. Now this is a quadratic equation. We can easily factorize it, and its factors will be alpha minus 7 times alpha minus 4 equals to 0. So we get alpha equals to 7 or we get alpha equals to 4. We are getting 2 values. Now that we have the value of alpha, we can also find out the value of alpha minus 1, which is the y coordinate of the center. So that's going to be 7 minus 1 equals to, 6, and if we have alpha equals to 4, so this implies that alpha minus 1 will be equals to 3. So we have obtained two centers actually. So there are two centers, means there are two circles possible. So one of the circle is going to have a center 7, 6, and the other circle is going to have a center 4, 3, and both of the two circles are going to lie on the line which is y equals to x minus 1. Both of them are going to lie on this line, and it also passes through the point 7, 3. Right. Now that we have the center as well as the radius, we can easily find out the equation by using the standard form of a circle. So let's also specify the standard equation of a circle. So if we have a circle with center having coordinate h, k, and the radius denoted by r, then the standard form of a circle is going to be given by x minus h whole squared plus y minus k whole squared equals to square of the radius. Fine. So we'll start with the circle with radius r equals to 3 units and center given by 7, 6. So we have x minus h. So h corresponds to the x coordinate of the center. So that's 7. We have x minus 7 whole squared plus y minus k. So k corresponds to the y coordinate. So that's 6. So y minus 6 whole squared. And this will be equals to the square of the radius. So that's 9. So this is one of the circle. And then we have the other circle with center 4, 3 and radius r equals to 3 units. So we'll have x minus 4 whole squared plus y minus 3 whole squared equals to 3 squared. So that's going to be 9. So there are indeed two squares possible. So let's try to look at it graphically. So here I have used the online graphing calculator Desmos to plot the two circles. The red circle denotes the circle having the coordinate of the center 4, 3. That's evident here. So this is 4 units and it's 3 units here. Right? And we have the other circle, which is the blue circle, that has a center 7, 6. And we can see that both of the two circles, their center lies on the line. So this is the line y equals to x minus 1. And they all pass through the points. Both of the two circles pass through the point 7, 3.